So here we're going to prove that there are no positive integer solutions to the Diophantine equation x squared minus y squared equals 1. This could also be written, if x and y are positive integers, then x squared minus y squared is not equal to 1. So we are trying to prove that x squared minus y squared is not equal to 1. Don't let the Diophantine equation confuse the matter. A Diophantine equation is an algebraic equation involving only sums and products and powers, and all the constants are integers and the solutions of interest are also integers. So we're trying to prove that x squared minus y squared is not equal to 1. Okay? So required to prove x squared minus y squared is not equal to 1 for all values of x and y that are positive integers. All right, so our contradiction says, suppose that x squared minus y squared is equal to 1 and x and y are positive integers. Okay, now x squared minus y squared is a difference of perfect squares, so I can factorize that. So I get x minus y, x plus y equal to 1. Okay, and since x and y are positive integers, x plus y and x minus y are also integers. Okay, now if I've got two integers, this is an integer and that's an integer, to multiply to get them to equal positive 1, well, either they have to both be negative 1 or they have to both be positive 1. Okay, so let's examine both cases. So case 1, x minus y is equal to negative 1 and x plus y is equal to negative 1. So equation 1 and equation 2. Okay, but x plus y can't equal negative 1 because x and y are both positive integers. So we're going to reject case 1. Okay, let's look at case 2. So for me to get a positive 1 there, x minus y has to equal 1 and x plus y has to equal 1. So x minus y equals positive 1 and x plus y equals positive 1. Okay. And if I add equation 1 and equation 2, you'll notice my y's go away. So I have 2x is equal to 2 and x is then equal to 1. And if I substitute x equals 1 into equation 1, what I get is 1 minus y equals 1 and y equals 0. But the problem with y equaling 0 is that we said up here that y is a positive integer and 0 is not a positive integer. So that contradicts, we've got a contradiction there, which contradicts that y is an element of the positive integers. Okay, so y can't equal 0. So therefore my supposition is false. And so therefore x squared minus y squared can't equal 1 for all integer values, positive integer values of x and y.